Right, so in the 2021 paper, that's paper question 2.1 B and C. Question said, well, you had a normal distribution, okay, and in that normal distribution, mu was 7.5, and it worked out that sigma, which was 45 minutes, is 0.75 hours. Question was, go find the interquartile range. Okay. Now remember, an interquartile range is the upper quartile minus the lower quartile. Okay, which means that 25% of your data, the lower quartile, 25% of your data lies below Q1. So in this case over here, you're going to have 25% of your data occurring in this region over here. Okay, so 25% of your data occurs over there. That's the lower quartile. So you're looking for the Z score that goes with the lower quartile. Okay, so we're looking for the probability that X is less than Z1, okay, is equal to 0.25. So H of Z1, this area over here between the score and the mean, okay, would also be because of that whole area is 0.5. So this area here is also 0.25. Okay, so you go to your table, okay, to find the corresponding Z score that goes with this area of 0.25. The Z score must be negative because it's to the left of that. Okay, so I end up with a Z score over here for the lower quartile of negative 0.675. Okay, then for the upper quartile, 25% of your data lies in this region, okay, over here, because 75% is below the upper quartile. Okay, so 75% is below the upper quartile. Okay, so once again, my H of Z score there, okay, is also going to be 0.25. So there's perfect symmetry in this graph, which means if the lower quartile has a Z score of negative 0.75, the upper quartile must have a Z score of positive 0.675. So the upper quartile Z score, because of symmetry, must be 0.675. So now I've got my Z scores that go with the lower quartile and the upper quartile. But now I need to find the X scores that goes with each Z score. So if I use this one over here, okay, Z is, and I'm going to find the corresponding X score that goes with a Z score of negative 0.75. Well, if I manipulate this formula, I get Z times sigma is equal to X minus mu. Move mu to the other side, and I get Z sigma plus mu is equal to the X value of your lower quartile. Okay, well, Z is negative 0.675, sigma is 0.75, and mu is 7.5. So I end up with an X score over here of being equal to 6.9938, which looks kind of right because that's 7.5, so that's to the left of it. Okay, so the lower value, so the lower quartile, in other words, is 6.9938. For the upper quartile, I do the same process. I'm using Z sigma plus mu. The only difference, okay, is that now the Z score is 0.675, okay, instead of negative 0.675. And I end up with an X score over here, which is to the right, which looks right. So that X score over there is 8.0063, right? So the interquartile range is going to be equal to Q3 minus Q1, which is 8.0063 minus 6.9938. And I end up with an interquartile range of 1.0125. In the memo, they used a Z score of negative 0.67. That's fine, but so is negative 0.675. It's actually slightly more accurate. Okay, so there is my interquartile range. Okay. Remember, your lower quartile, 25%. Lower quartile is the same as the 25th percentile. The probability that it's less than the lower quartile is 25%. Okay, the upper quartile is your 75th percentile. 75% of the data lies to the left of that. Here, the 90th percentile, the area to the left, under the curve to the left of the 90th percentile would be 90%. Okay, so, right. And the next question was a bit lame. Okay, it said, what's the probability that X is less than 8? We knew this from question A. From 2A, we knew the probability X is less than 8 is 0.7486. Okay, now they said in a sample of 200, how many people get less than 8 hours sleep? Well, it's just going to be the number of people times the probability, which gives you an answer of 149 people. Hope that helps.